Hi, in this video I would like to discuss the absolute extreme values. Suppose the given problem is determine from the graph whether the function has any absolute extreme values on closed intervals a to b. Then explain how your answer is consistent with theorem 1. Here few examples, those are 6 examples. Let us see one by one. This is the first example. First, let us see what is the extreme value theorem 1. If f is continuous on a closed interval a to b, then f attains both an absolute maximum value m and an absolute minimum value n in closed interval a to b. That is, there are numbers x1 and x2. Those are the points on x-axis in a to b with f of x1 equal to n, that is the absolute minimum at x1 and absolute maximum at x2, means that absolute minimum is less than or equal to f of x less than or equal to capital M, that is the absolute maximum for every other x in a to b. In this first example, that function is the given function is a continuous function and the intervals are closed intervals. According to this extreme value theorem, there should be absolute maximum and absolute minimum. From this graph, we can say that absolute minimum at C2, that is at x equal to C2, there is a absolute minimum and absolute maximum at B. That is an absolute minimum at x equal to C2 and an absolute maximum at x equal to B. Theorem 1 guarantees the existence of such extreme values because h is a continuous function and it is in the closed intervals. Next, let us see another example. Here, this function is also closed continuous function and intervals are closed intervals. So, we can say there is a absolute maximum and also absolute minimum. Okay, from the given function, we can say that absolute minimum at B and absolute maximum at C. That is the absolute maximum. That theorem 1 guarantees the existence of such extreme values because f is continuous on closed intervals AB. Next example. Here this function is a continuous function, but these intervals are not closed intervals. These are the open intervals. These points are not included. We cannot say that what is the minimum value, absolute minimum value, but we can say that this is the maximum value. That is the absolute maximum value. No absolute minimum. These are excluded. These points are excluded. Those are the open intervals. So, here from this graph we cannot say what is the absolute minimum value. And an absolute maximum at x equal to c. Since the function's domain is an open interval, the function does not satisfy the hypothesis of theorem 1 and need not have absolute extreme values. Here there is an absolute maximum, but there is no absolute minimum. Another example, these intervals are open intervals and the function is not a continuous function. There are discontinuities. So there may be exist that absolute maximum or may not the absolute values. No absolute extrema. We cannot say what is the absolute maximum. Similarly, we cannot say that absolute minimum value because that function is not a continuous function and there are no closed intervals. That intervals are open intervals. No absolute extrema. The function is neither continuous not defined on a closed interval, so it need not fulfill the conclusion of the theorem 1. Here the function is not a continuous function, but we can say that the absolute minimum and absolute maximum. An absolute minimum at x equal to a and an absolute maximum at x equal to c. Note that y equal to g of x is not continuous but still has extrema. When the hypothesis of theorem 1 is satisfied, then extrema are guaranteed. But when the hypothesis is not satisfied, absolute extrema may or may not occur. In previous example, there is no existence of the such absolute maximum or absolute minimum. Even though this function is not a continuous, and there are absolute minimum and absolute maximum. Another example, here that absolute minimum at x equal to c and an absolute maximum at x equal to a. Note that y equal to g of x is not a continuous but still has absolute extrema. When the hypothesis of theorem 1 is satisfied, then extrema are guaranteed. But when the hypothesis is not satisfied, absolute extrema may or may not occur. In this function, even though that intervals are open intervals and that function is a discontinuities, that function has discontinuities, even though there is the absolute minimum and absolute maximum. Let us revise all the examples. The first example, that is a continuous function and that intervals are closed intervals. So it has the absolute minimum that at x equal to c2 and absolute maximum at x equal to b. In this example, the function is also continuous function and closed intervals. So there definitely there are absolute maximum and absolute minimum. Here this at x equal to b, absolute minimum, at x equal to c, absolute maximum. In the example 3, that intervals are open intervals and the function is a continuous function. They are may or may not be occur those extreme values. Here we cannot say the absolute minimum value, but there is a absolute maximum at x equal to c. In example 4, that intervals are open intervals and the function is a discontinuity. That function is discontinuous function. It is not a continuous function. Here we cannot say the absolute minimum value. These points are not included. These are excluded. So we cannot say that absolute minimum and absolute maximum also. We cannot say what is the absolute maximum. These points are not included. These are excluded. Those are the open intervals. In this example, that intervals are closed intervals and the function is in discontinuity. That function has discontinuity, even though we can say what is the absolute minimum, where is the absolute maximum. That is, absolute minimum occurs at x equal to a and absolute maximum at x equal to c. In this example, also we can say what is the absolute minimum. That is, absolute minimum at x equal to c and absolute maximum at x equal to a. Thank you for watching.